So now a little bit into the integration status, the SRS data. So let me just go to this. That's why the slide is a little bit intimidating. So this intimidating looking slide, let me explain to you our general procedure here. So inside of the FDA currently, their data formatted in a kind of a text XML that approximates many of the things found inside of the standard. That's not there's no validation other than human validation going forward, and some is legacy data that needs to be brought in to a new system. So at the moment, while we're trying to test this, is to have this general workflow, which is we have this exporting script, which takes the data that's in the tables, does massaging to try to get things to the messaging requirements of the JSON schema. Those are raw dumps. We then importing a script which hits the API and then tries to register each one into the system. Then we, during this, it flags things that are validation problems, flags things that have logical problems and semantic problems. And then of those, we send out just an email report to our group to investigate what things are problematic in words and what things are problematic in some data transform and so on. The script takes also things to the API, as you can see. Then the current validation round trip that we do is we have some iterate through the API, then also round trip to get back out the JSON dumps after they've already been put in, and we have a record adapter which will try to re-approximate the tables that they've had. The whole point of this is to do that full round trip to make no data has been longer modified or extensively except improved upon entering into the new system. So, as this migration, those things are problem records. They really come into two kinds of categories, and this is really what a human has to decide as you go through. Things that can be fixed in the current model that the SRS, the FDA is using, and things that cannot be fixed. So what we've been trying to determine which ones of these are available. Those things that can be fixed, so that the model supports fix, and it just needs to be implemented and changed inside the FDA. Some in their current system is that they need to convention that they add inside of their system that will, on a migration, it will pull in just right. They'll need to actually do some manual entry into GINAS in order for it to be populated. I would actually ask if there are any questions, even so far, what the meaning of this talk is of that nature. I think for strong introduction.
Integration schema, people have things in other databases.
Sure. No.
If they have a mold file, I mean, there used to be, you get the H views and you can have, so are we have a tool for that? Do you foresee? Or
so I think what will happen is we'll have a very basic, very basic exam tool that hits the API and shows you how to use it. The same way down here. This import script especially will very likely become an exam tool to be able to compose these messages from our data and try to hold something to hit the API.
So from proteins and polymers, of course, we'd probably never be able to design a good migration tool, but for chemicals, proteins, and nucleic acids, at least we could, if we had structure, name, codes, we could bring all that in pretty.
So I'm coming to that. The data that we've done, at least for the data inside the SRS, is that we've done certain rules that will map them into the new schema, and then validation procedures that go through flag certain questionable content and things that don't seem like they're. Certain things are automatable, certain things not. I think that the data in the SRS is is 100%. It's similar to every other data source. Of course, every data source is unique. But so if for very simple things, if someone just wants to do name matches, of course, this would be much easier than this. But if someone wants to migrate what is already detailed information into the format, these are the kinds of ways that they could do it by these kind of API scripts that they'll be able to go through.
Like an SDF, you foresee having an SDF to Jason over there.
Yeah.
Okay.
Okay, let me explain that a little bit. So the SRS Oracle tables, the actual database that they use is a series of tables that are inside of they're running in Oracle database. In order to do a round trip validation of the data, the idea is to go all the way through the registration process with this data to transform it, and then circle back and make sure that nothing that the tables that have come back that would be recreated here after round trip would be consistent. Does that?
How you validate the migration process?
Yes.
The data. Are you the level of information or?
Yeah. So there are a few areas where that's enriched, but those are also flagged. Those are flagged as certain reference additions there. So there's some other data that's added here that's imported as well in the import scripts. That information is not passed through. Yeah. So for instance, we have naming translations of things that are not on the native Oracle tables of the SRS. We inject in here and some data from NCATS that we inject to make sure that these all gather. In order to validate this procedure, we want to make sure that all of that same data comes out in the same format on the other side. And actually, this talk is really for those who are interested in where we're going at the in the migration general scheme for the FDA. These are very particular things to the FDA, and these are particular problems of the FDA. Some of them are going to be similar to other agencies, and some of them are not. So one of these is a large log of different warnings and problems, issues on import. So we just produced a large Excel file that will just flag records that are problematic, that either failing the validation or had some warnings or had some general issues. This little Excel add-on that you've seen, which allows you to see some of this information. We have IDs or names. We can find out what it was about them that was problematic. We can resolve them to other structures. You can see it like this. So I could say, here this chemical structure looks like, and you can see it from L by hovering over cell, and then see what it looks like when it's salt stripped and so on, and then see why. And often you'll be able to determine some general understanding of why some import was a problem. So the issue that kind of comes up here for the FDA is in some BNUM cardinality. So I just want to mention what BDNUMs are. BDNUMs are the oldest numerical records that the FDA has. They've never been public. They're just these IDs that are used, and they're used internally. They eventually kind of became mapped to unis. But this has been their model, was that a uni, a substance, many BDNUMs, and those BDNUMs have names, codes, and relationships.
Just to give you how old it is, stands for Bureau of Drug.
Yeah, that's right. So uni is really something that sits on top of that BDNUM to qualify and give it some definition. So really, a very long time ago, the ingredient dictionary was just a collection of terms and with a little bit more information. And then when the SRF came along, it was adding some real definition to what those terms meant, and there was a mapping for where the unis fit on BDNUM, but there may be more than one BDNUM that maps back to this.
Because all those leads connected to the application, there's a lot of links.
Yeah.
There's also that.
So explain this, substances may have ingredients, so they call the mediums the ingredients because they may be more specific or less specific than a substance tends to be. And ingredients may have any substances. You have ingredients which have a substance pointed on top of them. These tend to be the things that we consider concepts in GINAS, like purities and so on.
Or just the concept of lecithin.
Yeah.
With not egg lecithin, soy lecithin,
So that we view this is actually this way, that a substance is exactly one concept, and a concept is not necessarily a substance. There's a substance. They're similar. But the cardinality between substance and concept is one, whereas here between substance and ingredients, there's many. So that happens. One has to do with those things that are meant to be specified substances, but since they haven't yet, the FDA never hadn't implemented substances yet, they were linked together, like water, ice, steam, and liquid water, right? So the substance uni was water, to several collections of terms which are together. Steam and liquid water. The issue here is what these should really become is these should become specified substances in the future. So be able to identify those things that are meant to be specified substances and have them re-enter and import, not along with the substance record, along with new record that is a specified substance record. Does that make sense?
when you package, you've got an injectable, right?
Yeah.
How that may make a difference in the way you use it.
Other scenarios, which I think that are really just legacy merges. I've made up these terms. I don't think they're actually real associating with things, but just to give you an idea of what can happen. There are times when, especially prior to having specific definitions for substances or ingredients, one record where someone would call it by a code name, and another record where someone would call it by IUPAC name or something like that. And those two BD nums were eventually merged into the same unity, but they're kept as separate concepts. Really, they have no further. These are exactly the same concept. They're only there for legacy linking purposes, and we'd really like them to merge into the same concept with BD nums deprecated. So this gets a little bit too specific. But let me just mention that the basic thing to say is that we have plans then to be able to identify those things that are concepts that are of the first part, and those concepts that are concepts of the second part, and those need to be identified in order for proper migration. Right now, if you search in the system, you'd see even initial migration that the distinction between some of this information, they're searching the same substance record, and much of that information needs to be pulled out to a specified substance record rather than in the substance record it's been in. And it's saying that this information isn't exactly wrong. It's just not significant enough. So it is still true that the need for ice, that the substance used for ice is this uni. It's just not true that the specified substance uni for ice is that. Yeah, a specified substance is that record.
You don't exist yet.
Yeah.
Well, so much is.
Yeah. That's right. So as we walk through a little bit, I guess actually we got interrupted exactly as I was getting into this now that I think about it. But a specified substance functions a lot like a mixture to some regard. It's usually one substance record plus some other identifying information. So think of a specified qualified substance, something beyond the initial definition of a substance, so a little bit more specific on top of it. But it always still points downward towards what a substance is. Good question. No,
salt typically,
but
that's a salt, sea salt.
Those things depends, but no, so I think it is somewhat arbitrary in that one can imagine a system where that was the case. A salt form would be a particular specified substance. In this, we consider any kind of stoichiometric molecular ensemble to be considered an individual substance. Anytime you're getting more specific than that, then we tend to say that it's
some decisions we made that may not have been the right decision, but if there's stoichiometry, like Tyler said, we would do it if, when they're getting non-covalent interactions. It's tough. The only things we take with non-covalent interactions are usually salts, solvates, like whenever you mix anything together, you're getting some sort of interaction. So the INN many years ago with cyclodextrin complexes gave them separate names. We haven't done that. For polymers, most of the time polymers bound it to drug. We haven't, and there's a lot of polystyrex drugs. So those, again, would be like how it's specified substance, because you would vary the amount of polymer and drug depending on the formulation and stuff like that. And even excipients like carboxymethylcellulose, if you have a base there, it's really sort of acting as an exchange thing, and something down release. And so that's why a lot of these, and isopane insulin, where, you have, that's not a substance. That would specify substance. So Tyler said it is somewhat arbitrary.
Yeah.
And
if in the world, the first the hydration part is probably the one that I think is make a little bit more sense to be a substance one. I understand why it's not, because there's a stoichiometry there that's important. But right now, that the dividing line really is that.
Yeah, and we initially, if there were two alkaloides in a complex of salt form, we would say those are two drugs. But now, like pain penicillin, we call it a single drug. Now, if there's geometry, stoichiometry is the writing factor, not whether it's active or inactive. So yeah.
Usually, if there's a discernible strength-moiety relationship, that's going to be a substance.
Maybe there's that relationship, we can still call it a substance.
About this concept, it's a little bit empiric.
We're not where you combine drugs the same, like Persevere has a CAS number, so we'll never have a uni for, three substances together, they'll always be separate, at the product level. So anything that's an intentional mixture, that would be separate.
So to this, I was going to mention was this last part here. I'm just going to explain how it is that we're going through this. Currently, there are these kind of 5 tables, some legacy systems that the FDA need to work with, and need to kind of validate some trip agreement. General way of doing this is just that we will take out we just have adapters that take out JSON, look through the different fields you've already seen inside of those objects, and try to constitute approximations of these tables, which will just be validated against each other. The thing about this is that the given tables right now are actually specific. They have a limited set of alphabet, so only so many. So everything has to be standardized in a certain way. Everything is uppercase. There are no foreign characters other than these additional codes that are allowed in there. And this is problematic because the FDA wants to expand into being able to support all of these foreign language translations and so on. So when we go parse back from the more featured genes of these, we have to be able to adapt them back into this unfeatured version, which is which is certainly a lossy transformation. This is somewhat useful. It just means that we can't then consider if something is going from the SRS the current SRS into GINAS and then back and back to there. That's fine. What's not okay is then to expect that something you've put in the system would survive the same round trip. So this is probably a little bit too specific to none of the user in there. That's too bad. Actually, I think I probably have a version of this. What I was going to show is there's a running log count of some of the various issues that will come up. Some of them are kind of funny. Many of them are just little stereochemistry warnings that are in the initial system. Some are odd circular references where a substance is defined by itself, which is defined by itself. Most of these that we've been working through, Rick and Larry and a few others have been really making the data, I think, much better as we've gone through these exercise of validation. But so I believe there are more slides there, but I think I've misplaced them.
How often do you do migrations? Regarding?
So right now it's about once every other week. So in the future we plan to get this down to about once a week, and then eventually it will be somewhat continual. But this is an important piece for us to really validate everything, and even to make sure that there's nothing completely on any step along the way. Each one of these is somewhat crucial to demonstrate. Any migration? And just say, from where we are there any larger scale questions, any larger scale discussions? The rest of the theoretically 3 hours of scheduled, and we have about 2 hours remaining. Some people actually have to catch flights, I imagine. But yeah, okay. Anybody who needs to get anywhere, okay, that's great. This next one, I think we might want to just take just a few minutes break, just kind of wake up and move around, shake off and stuff. Too much coffee.